Hey guys, my name is Aaron and I would like to give you all an opportunity to learn more about the most recent XRF unit we have added to our rental fleet, the SciAps X-550. We now carry the SciAps X-550 XRF in multiple different models. We have the X550 PB and the X550 Geochem. The X550 PB is only equipped with lead paint mode, while the X550 Geochem is equipped with both lead paint and soil testing modes. A key difference with these is that all the SciAps XRFs in our fleet are HUD certified for lead-based paint testing. The X550 Geochem can also detect many key heavy metals, including the RECRA 8, CAM 17, and 12 out of the 13 priority pollutant metals. Both units are also tube-based XRFs, meaning there is no radioactive source in the device and X-rays are only emitted when the unit is fully powered on and the trigger is held. So what does HUD certified exactly mean? HUD certified means it has been built and meets the standards set by the U.S. Department of Housing and Urban Development. One of these requirements is the evaluation of instrumentation and the publication of a valid performance characteristic sheet by a third-party laboratory. Many states and municipalities have adopted their own regulations regarding to the level of lead in paint, lowering their limit from this HUD standard of 1.0 milligrams per centimeter squared to 0.7 milligrams per centimeter squared or even 0.5 milligrams per centimeter squared. The X550 has published PCS documents for each of these levels, which comes included in our rental package. We mentioned the RECRA 8 metals earlier. What are they exactly and why are they important? The Resource Conservation and Recovery Act, known as RECRA, is a law that regulates the safe management of hazardous waste in the United States. The EPA has considered the RECRA 8 to be particularly hazardous because they are very toxic and can have serious health and environmental impacts. Arsenic and lead are some of the more commonly found metals, but each of these are dangerous as they can leach into the soil or groundwater when landfilled and can have a wide range of adverse health effects. The X550's ability to scan for each of these elements makes it a key instrument in keeping our soil and water safe. Now let's talk about the priority pollutants. In 1972, the Clean Water Act was passed to prohibit the unlawful disposal of toxic pollutants in United States waters. In this act, the EPA outlined lists of toxic pollutants that would present harm to the environment and therefore require federal regulation when being disposed of. They can be separated into three main categories: metals, pesticides, and volatile/non-volatile organics. Frequently found in wastewaters, these are considered toxic due to their detrimental and harmful effect on environmental and human health. The X550 can scan for each of the metals listed, except for beryllium, as it is too light to be detected by XRF devices, making it an extremely useful screening tool when looking for these elements. The X550 is lightweight, and its combination of intuitive menu design and use of the Android operating system make it a versatile, easy-to-use tool. Once the unit is booted up, it will prompt for a calibration check, which simply involves placing the small stainless steel beam cover over the end of the gun. This checks to make sure all internals are working properly and safely. When checking for lead paint, the unit will also prompt for a PCS cal check to be completed before sampling. All this involves is scanning a 1.0 milligram per centimeter squared lead paint sample 3 times. This can be found on the wood block included in the case. We'll go over exactly what that looks like in a little bit. Using the X550 for soil testing is just as simple. Just follow the same calibration check method and you are good to go. There will also be a soil standard reference material included for you to check your results. Elements will be listed in order of concentration found, but this can be easily changed in the settings, along with many other customization options, such as adding notes or pictures to each sample. Once out in the field, you may find yourself using one of these common field screening methods: in situ soil testing, which is where you use the XRF to measure the metal concentrations in the soil by directly placing the instrument on the surface of the ground. This comes without any further sample processing. You could also do the bagged soil method, where you take a soil sample and place it in a thin plastic bag, which you can then just scan directly with the gun through the bag. While handheld XRF units can be incredibly useful, it's important to keep in mind that they do produce X-rays, which are harmful to all living things. When used with the proper training, however, the risk is very slight. It's up to you to be the responsible operator. The most important thing to remember is ALARA, as low as reasonably achievable. Always keep the unit an arm's length away while testing, and only pull the trigger when it is directly on a sample. Field environmental instruments requires anyone who uses one of our XRFs to be radiation safety trained. We do, however, offer free radiation safety training to all of our customers, whether you have an upcoming rental or not. If interested, contact an FEI office near you. Thanks for listening, everyone. Now, before we jump back into it, let's go through a quick little overview of what using this instrument actually looks like. Here's your SciAps X-550. Let's go ahead and open the case. You can see here's our HUD certification sheet, characteristic sheet. And here is our actual gun. Our power button right on top here. You can see the instrument booting up. We can also see in our case here's what our lead paint sample looks like, as well as our soil sample. Now that we're all booted up, it'll have us input the username. Simply just keep this as admin. It'll ask for our passcode, which will just be 12345. Gives us our warning on X-ray radiation. From here, you can see there's really only 3 options it gives you: analyze, settings, and results. So we're ready to analyze. We're just going to go ahead and tap that. It'll ask us choose our application. Let's start with lead paint. Now it's asking for the calibration check, which we mentioned earlier. We simply use the stainless steel beam cover for. This just slots right in over the top here. And we'll hit calibrate. Red lights are on to show that it is currently shooting X-rays. Should take 15 seconds to do your calibration check. Once we're green, we're good to go. Now, since we're in lead paint, it is asking for the PCS calibration check. We just simply grab our wood block here. We're going to tap PCS cal check and then scan our sample. First check passes. Now we just need to do 2 more. After that, it'll say PCS cal check pass. You just hit this arrow. We'll get back to the camera screen, and now you're ready to start sampling. We can scan our blank. See, it comes up as negative. Now let's take a look at the soil application. Just go ahead back here, hit soil. We already did our cal check, so we don't need to do anything else. Let's go ahead and scan our sample and see what that looks like. You can see it's populating each element here as it's detecting them, and it's listed by concentration. Once we're all good, we can see on the screen here, it's just showing us everything it detected. From there, you just hit that arrow and you're ready to scan your next sample. Once you're done, all you do is hold the power button up top here. It'll prompt for power off, and you're good to go. And that's all it looks like.